Okay, we're in circular motion, two-dimensional, 2D circular motion, problem number 6 on the web assign. We have the Milky Way galaxy rotating about its center. So here's the Milky Way, and at the very center, objects are orbiting around it. Here we have our sun at some particular place. I'm going to call that radius again because it's the radius of orbit of the sun. Here at the center is a supermassive black hole of 4 million solar masses, but that's beside the point, even though it's pretty cool. The sun's distance is given, so actually this r is equal to 2 times 10 to the 20 meters. That's a whole heck of a lot of meters. That's about 26,000 light years. How fast is the sun moving with respect to the center of the galaxy? I shouldn't have to go over this with you, so let me keep my comments relatively short, if that's possible for me. And we're looking for how fast it's moving. V, question mark. So if you want V, if you think of the centripetal force associated with this, since that's the unit we're talking about that in this unit, we have mv squared over r. That's the centripetal force. Well, we don't know the force, and we don't know speed. There's too much we don't know here. We don't know the mass either. However, that's equal to m4 pi squared r over t squared. So that's our other formula for centripetal force, or one of the other ones. If this is where you started, you realize, because it gives you information about the period. Now the masses go away. We don't care about the mass. But we have information about this, so maybe that'll help us. Solve for v squared. V squared is equal to 4 pi squared r squared, because we have to bring that over t squared, or v is equal to the square root of all that, which is 2 pi r over t. Oh, but maybe this already looks familiar. This is just distance over time around a circle. 2 pi r over t. Very good. So now you can just plug it in, and be careful about the plugging it in. 2 pi times 2, I'll say E20, all right, 2 times 10 to the 20, divided by the period. Let's see, is that a variable also? Yep. I had 205 e to the 6th times 10 to the 6th years. So it's many years, but we need to have standard units of seconds. So 365 days per year. Multiply that by 24 hours per day. Multiply that by 3,600 seconds per hour. Everything divides out. I mean, hours go away, days go away, years go away, and we end up with seconds. And for the values that I have here, you should get something like 194 kilometers per second. And there you go, folks.